Hi, welcome to this video on my BeagleBoard Classic revision C4. In this video I want to use it in combination with some external interfaces. First, it is connected through HDMI cable to my monitor, which is this one. However, due to the fact that for some reason my keyboard and mouse, which are correctly working, are not working on my BeagleBoard, I have to rely on USB and serial cable for connection. And via USB I am connected through VNC server via wireless. And also through wireless, no, not through wireless but through USB, I have attached a robo interface from Fischertechnik, which is connected through radio frequency data link to the interface. And this little board here is the other side of this one, so these two stay in contact. And previously I used devices like this, or this device actually, on a normal laptop. However, the BeagleBoard is an ARM device, and I'm curious how this will work and if it will work like the other computers. So I've installed the libft library, which is open source and uses Python for the robo interface, and I will see how far I get by using it. So that is what I'm going to do, using motors and all kinds of other stuff. So let's see how the software is going to work. To start this new combination of the BeagleBoard and the robo interface, quite simple. Another Python program. I already installed the robo interface Python library, which I've used before. So I import everything from the robo interface. I import sleep from time. Then I get the number of USB devices attached. Then, this is quite important, each robo interface comes standard with serial number 1. However, through Robo Pro you can reset that and get the real unique serial number. In this case it is 15050. Then, if there is actually an interface present, then print the number of devices. Here, set output is meant to use one of the motor outputs. There are 4 motors, and each of the four motor outputs has a separate output number, and those run from 1 to 8, and I'm using 1, not to use a motor, but to burn a lamp, and I do that for 2 seconds. So let's run it. It says number of devices is 2, and of course in the screencast you can't see that it actually burns, but I will show on the camera that it actually does. So let's go to the camera and see how that works. So in this setup I'm using output number 1, which I have connected on one side to the lamp, on the other side to the mass, and it should burn at half of the brightness for 2 seconds, as I showed in the screencast. So I run it again, and here you see the LEDs, the LED for the data link working, making contact with the board inside the robo interface, and you see it burn. So let's do it again. Making contact, responding, burning for 2 seconds. And that shows that in any way this is working nicely. The thing is, however, that I'm operating at 2 different voltages, because the BeagleBoard runs at 5 volts and this interface runs at 9 volts. So it's getting its command from the BeagleBoard to here. So that brings the question, can I run a motor? Yes, of course I can run a motor, so let's attach one. In order to have a lamp, the motor run nicely, I have to program it, of course. So, to set motor, and now I have to set which motor, which direction and the speed. So I've already used output 1, which belongs to motor 1, so I have to use motor 2, which is just 2. Direction, let me do it to the right side, so effectively that means clockwise, and again half speed, and let's run it for 2 seconds. And should that do it? I think that should do it. Let's just run it once to see that there are really no errors. And there are no errors, so let's see on camera what actually does happen. So with this motor, including the fan connected to motor output 2, let's effectively see what happens. So first the lamp, and that shows nicely. Just running it again. And that asks for another input and output, namely the sonar I have, which is this one, ultrasound, which will go to the distance connection. So let's put it in it. Let me see which one is which. Let's use, I guess this is one. And then we can always see what actually does happen. So let's program it. And to program the ultrasound, which means the sonar, it is set to the, or connected to the digital output. So of course I have to put in digital, and I'm using 1. And the whole point is this gives a signal. So I can't just use this. I will have to and that means just use English here. And this should do it well. Insert in Dutch as well. So, distance will be in centimeters with a minimal distance of minimal correct distance of 2 centimeters. Within 2 centimeters it won't do anything correctly. This should do it. Let's see if there's no error. It says 0. Question is that indeed true? I'll put it somewhere else. I'll run it again. Still 0. So maybe I made an error and this should be 2. Still 0. So the question is, did I correctly use it? That is a big question. I'm going to replace it into the other one. Try again. Still 0. I have to see why it does 0. I probably make a slight mistake. Yes, I am, because I have to set distance. It has to use distance, and I have to look up how I should do that. So that's up next. And yeah, I have to indeed correct something, because to enable the sonar I have to put here enable dist is 1, but also it is not digital 1. Digital 1 is a very different input. It does exist, but not for sonar. It is get D1 4 1. So this should be correct, and if it doesn't give anything, it should be get D2. That said, let's put it on D2 because I think that's it. Let's run it. And that is much better. As you can see, there's an object at 28 centimeters, which is, I think, the camera. So let's actually see how it attached, and well, you saw how it is attached, I think. But anyway, this is how it works. So right now it looks like successful test in the BeagleBoard. But yes, let's do another camera. So as you saw on the screencast, the sonar actually works, and you can only see it in the program that it works, because you can't hear it. That's why it's called ultrasound. But anyway, let's see something. It would be fun to see the lamp working as well, if it wants to cooperate. And of course you can have fun with it by having the motor run when something approaches the sonar. And then you can actually see it does work. Well, let's just do that. Have it run that way. So to have that plan, the combination with sonar and motor work, then I can leave this as is and say if t dot get d2 smaller than say 5 centimeters, in that case t dot set motor, let's have it run the other way. X motor 2, counterclockwise, 4 again, put on some 2 seconds. Let's see how this works out. I'm curious. So let's see if it is without error. No error so far. That looks like functioning okay, with a distance of 4. So let's see on camera. And to show that it does work, I start a program, keep my hand here, and I hope you could see that it turns the other way. So let's do it again. There it went one way, and I kept it too far away from the sonar. And this is too much, so shorter than 5 centimeters proves to be a little bit of a challenge. But how much challenge can something be? Let's just put some it should do it. And that is odd for no response, but anyway, I think you saw it working. Shorter than 5 would do this. I do hope so. Another test. There it goes. So this is interaction with sonar and motor, with lamp burning, and for a first demo in combination with the BeagleBoard. Looks like a fun thing, so I guess more fun to come in next episodes. For now, thank you for watching, and to be continued.